Hello again, I am Jeferson Martinez, taking into account the ensuing from phase 2 and putting the improvement plan to into action. In this phase, I proceed to make the following optimizations to achieve better performance for our game. Okay, in phase 2, the profiler showed three clear issues. First, 95, 96, excuse me, beige, and 45, 47, excuse me, 7 Pascal, and which are very high for static scene. And second, the texture memory was at the 156 0.4 megabytes, and third, the render textures will consume the 105.6 megabytes. Okay, the first thing I optimized was batching. I filtered the hierarchy by the image renderer, um, selected all static objects, uh, floor, walls, um, boxes, and enabled the static checkbox, especially checking basic static. Okay. Um, 10, 10 under edit project settings player, I confirmed that static batching and dynamic batching were enabled. Since I am using the built-in render pipeline. Most importantly, I remove duplicate materials, um, such, such as the files I kit hauled. I had 4 loaded colors, and I only use the white one. By deleting the other 3, Unity stopped making those extra draw calls. The second time was texture memory. I filtered by the texture 2D and tackled the two Hibits ones. The metal claro texture was an uncompressed 4K. I downscaled it into 1024 and the format in RGB crunched DXT1 debe salir button was at the 2K. I lowered it in 511 and applied the RGBA crunched DXT5 BC3, and because it has transparency. I also compress the 4 textures. The 4 textures of the white fields I kit to 511. Everything was set white and non-power of 2 and none. Finally, I optimized shadows and render textures. In the project settings quality, I changed shadows to hard shadows only, shadow resolution to medium, shadow distance to 16, and shadow cascades to 2. On the directional light, I kept bias at the 0.05. With that, I reduced the shadow rendering, where lack a way to it paint visually noticeable. And now let's move onto the comparison. Under rendering, we previously had 96 beige, and now we have 54 beige. We dropped from the 47 set pascals, and now we have 42 shadowcasters with from to 42 and now to 13. On the memory, texture memory went from um, to 256.4 megabytes and to 1 to 223.3 megabytes, which is 33 megabytes less. Rendered textures dropped um, from 105.6 megabytes to 74.5 megabytes, and the total graphics memory went from 108.6 megabytes to 178.6 megabytes. In total, used by compressing two textures and cleaning at duplicate materials, I framed at over 16 megabytes of VRAM and could draw calls nearly in half, while maintenance the same 1000 two triangles and the stable 120 FPS. With this, I concluded past 3. The most effective optimization was the twinking code. I was cleaning up assets and using Unity proper compression. That's for waiting.